Hey, it's Ruth Marie, and I'm super excited to be able to bring you a bio lesson in 10 minutes or less. Today we are going to be focusing on hypotonic, hypertonic, and isotonic solutions. This is a topic that some students can have a hard time grasping. There's a couple of misconceptions and a few areas where students can misstep, but I'm going to take you through a step-by-step process to make sure you fully understand what's actually going on in the whole process in hypotonic and hypertonic environments so that all that confusion will just go away. And first we're going to look at the definitions of the terms that I just went over. So our first term is hypotonic. Hypo, the prefix, is a Greek prefix meaning beneath, or some translate it as low. We usually translate it as low in biology because of the way we're going to use it. It's easier to explain that way. And an easy way to remember that hypotonic, the tonic is just referring to the solute, so low solute is what this word means. And an easy way to remember this is low solute, okay? And that is how I encourage you to remember hypo, low, all right? Our second word is hypertonic. Hyper comes from the Greek prefix meaning above or high. And this is easier to remember because we use this prefix a lot more in everyday language, especially when we refer to high energy children as being hyperactive. They have a high energy level. So hyper means high. So instead of hyperactive, in today's lesson we're going to be using the term hypertonic. So instead of high active, we're talking about high solute. And the last term I mentioned briefly before is isotonic. And I'm not going to go as far into isotonic because it's a lot easier for students to understand. Iso means same, so the same solute. So it means that the solute is going to be the same both inside and outside of the cell. And the cell isn't going to do anything. It's just going to chill because it's in an environment that's in equilibrium. Okay, so now we are going to go through a step-by-step process to determine what happens to cells in these hypotonic and hypertonic environments. So first we're going to draw a cell, and outside the cell we have a 0.1 molar sodium chloride solution, which is just salt, and inside the cell we have 0.5 molar sodium chloride. Now our first step is to determine which number is bigger. So 0.1 is less than 0.5, so we're going to record that. So the environment, which is the whole area outside of the cell here, has a low concentration of solute. And brackets are just a shorthand way to say concentration. So inside the cell, we have a high concentration of solute. And as we remember from our definitions before, hypo, low, so in the environment, which is how we're labeling this, we have low solute. So hypotonic, so we're going to label our environment over at the side, hypotonic. Our third step is to determine where the high and low concentration of water is. So all we do to do that is we look at the high and low concentration of solute and we write the opposite next to it. So the environment has low solute, so we write high concentration of water. And the inside of the cell has high solute, so the opposite would be a low concentration of water. Now, this is where you need to be paying attention. This is our attention point. This is where a common misconception occurs. A lot of people think that because we talk about the environment in terms of the solute, hypotonic, low solute, that it's the solute or the solvent in this case that is moving. However, this is not what is going to happen. As we talked about before, this cell has a semi-permeable membrane, which will allow some things to pass and some things not. So water can pass freely through the membrane whenever it wants. Salt, however, is too large and it won't be allowed through. So water moves by osmosis from high to low concentration, and that's the driving force of this scenario. So our fourth step is to draw an arrow from high concentration of water to low concentration of water right here. So if water is rushing into the cell then is going to swell and become a big, huge cell. So we see here, in a hypotonic environment, the end result is that the cell swells. And you can remember this by thinking hypo, just like hypo low, hypo fat. Hypotonic solution, fat cell, hypo. Okay? So now you're going to talk about the opposite scenario in which we're going to have a 0.5 molar concentration out of sodium chloride outside of the cell and a 0.1 molar concentration of sodium chloride inside of the cell. 0.5 is higher than 0.1, so we're going to label our concentrations in blue. High solute outside, low solute inside, and which means our water is low outside of the cell and high inside of the cell. And because we have a high concentration of solute outside of the cell, this then is a hypertonic environment. So the water is going to rush from high to low by osmosis, from inside the cell to outside. And so all the water leaves and the cell shrinks. Now we can remember this by thinking of a small toddler. So my niece, for instance, my goddaughter, has this really little pipsqueaky voice. She's 2 years old, and she runs around saying, "Hey, Miss Ruth Marie, I'm going on a trip. I'm going on a trip." And she runs around and she pretends like she steals all my clothes and she pretends like she's going on a trip. And eventually, she runs around with my suitcase and then she gets tired and she has to lay down, right? So, hypertonic, little pipsqueaky voice, hypertonic. Hyperactive child, little pipsqueaky voice, little bitty kid, crashes, the cell shrinks. Hey, so now we are going to do a quick fire lab to illustrate hypotonic, hypertonic, and isotonic. So first, I'm going to take this red gummy. He's going to be in a mimic isotonic environment. I say mimic because he's just going to be in air instead of a true isotonic solution where the sugar would be the same amount as in the gummy. I just don't have the equipment to do that. So he's in a mimic environment, and then we're going to take this green gummy here and we're going to dump him, the green gummy, in a hypotonic solution of just pure water. So there's low solute, high water outside of the gummy. And then we're going to take the yellow gummy and we're going to place him in a 50% salt solution. So it's a hypertonic solution, high solute. Then we wait 24 hours and we look at our gummies. So over here, remember iso means same. So nothing happens to the one in the isotonic. They stay the same because the solute is the same in and outside of the gummy. The hypertonic gummy is the yellow gummy. So he has a high amount of solute and a low amount of water outside of the gummy. So the water inside the gummy rushes outside and he shrinks up. So this is 24 hours, this is 48. And then my favorite gummy is the green gummy. He is in the hypotonic environment. And so there's a high water, low solute. So the water rushes into the gummy and you make a king-size gummy. And that part of the lab is really fun to do with little kids because they can make their own king-size gummies, and I highly encourage that. Anyway, that is all I have for you. If you have any questions, please feel free to leave a comment or you can tweet me at Miss Ruth Marie. Thank you so much for watching.